Welcome to This Explainer. Today, we're tackling a topic that is literally the backbone of aviation safety. And the crazy thing, it happens entirely behind the scenes long before an aircraft ever leaves the ground. We are going to completely break down the mechanics of aircraft weight and balance. I'll guide you step by step through exactly how a load and trim sheet is actually calculated. We're going to take all that complex technical math and turn it into simple, logical steps that are super easy to follow. It's a seriously fascinating process, so let's jump right in. But, before we start crunching numbers, we really need to understand what's at stake here. What actually happens when the center of gravity is ignored? Or what if the calculations on the load sheet just don't match reality? Well, tragically, the answer can be catastrophic. On Christmas Day back in 2003, a Boeing 727 operating out of Cotonou crashed, resulting in the heartbreaking loss of 141 lives. And the main culprit? A perfectly flyable aircraft was pushed way outside its physical limits, all because of a severe misunderstanding of its weight and balance.
Let's break down the timeline of that fatal sequence. Before the engines even started, this aircraft was already in deep trouble. It was significantly overbooked, and the loaders were just frantically stuffing heavy cargo into the forward hold without properly tracking it. By the time the takeoff roll began, the outside temperature was a sweltering 32 degrees Celsius, which, as we know, already reduces lift. Because the plane was so overloaded and the center of gravity was shifted drastically forward, the pilot literally could not lift the nose. The nose wheel didn't even leave the ground until the 2,100-meter mark on a really short runway. And by then, it was just too late. The aircraft couldn't climb in time and struck a building. This is exactly why mastering this topic is absolutely vital.
Okay, let's dive right into this. Here is our roadmap. We are going to systematically walk through the vital importance of catching errors, how to calculate basic weight limits and traffic load, cargo distribution, plotting the trim and CG index, and finally, we'll wrap up with modern automation solutions.
Starting with Section 1, Vital Importance, Errors and Accidents. I cannot emphasize this enough. Understanding these calculations isn't just paperwork. It's a matter of life and death. The load sheet is the ultimate safety contract between the ground crew and the pilot.
Consider this wild, chilling incident from July 2015 involving an ATR-72 taking off from Dublin. The intended load plan, which was officially signed and handed to the captain, stated that 421 kilograms of baggage was safely stowed in the aft or rear hold. But the actual loading? The ground crew mistakenly shoved all of it into the forward hold. So when the captain pulled back on the controls to take off, the nose was terrifyingly sluggish to lift. The entire aircraft was severely nose-heavy. Thankfully, the pilot realized what was happening, adapted his landing speed to keep control, and landed without anyone getting hurt. But it goes to show, right? A piece of paper is only as safe as the physical loading it actually represents.
Moving to Section 2, Calculating Basic Weight Limits. Preventing these kinds of disasters starts at the very beginning by strictly calculating the actual structural limits of the aircraft.
Think of filling out a load sheet kind of like building a house. You got to start with a solid foundation. Step 1, we take the aircraft's basic weight. That's just the empty plane right off the factory floor. Then we add the weight of the crew in the pantry, the catering and galley supplies. Add those together, and you've got your dry operating weight, or DOW. This is your fully prepped aircraft just sitting there waiting for fuel and passengers. Step 2, you take that DOW, add your takeoff fuel, and boom, you have your baseline weight before a single piece of commercial payload is even added.
So the absolutely crucial point here is that you have hard, physical, structural limits you can never, ever exceed. Take a Pegasus Boeing 737-800, for example. Its maximum takeoff weight is 79,000 kilograms. You basically have to calculate 3 different maximums: your max takeoff weight, your max landing weight minus the trip fuel, and your max zero fuel weight plus your takeoff fuel. The golden rule of load control? Calculate all 3, and you must always, without fail, obey the lowest, most restrictive limit. In our example, that hard ceiling is 79,000 kilos. If you mistakenly go with a higher number, you might think you have room for an extra 400 kilos, which could literally tear the aircraft structure apart.
All right, Section 3, Traffic Load and Passenger Distribution. Now that we know our absolute maximums, let's talk about the humans and the bags we are actually getting paid to transport.
Now, obviously, we don't put passengers on a scale before they board. That would be chaos. Instead, aviation relies on strict standard weights, especially for high-capacity flights. An adult is typically calculated at 84 kilograms, a child at 35, and legally, infants under 2 years old, they're calculated as 0 kilograms. Why 0? Because they don't take up a physical seat and are held by an adult. Their weight is statistically absorbed right into those adult averages.
So, how do we figure out exactly how much traffic load we can safely bring on board? It's literally just basic subtraction. Step 1, take that lowest, most restrictive allowable takeoff weight we figured out earlier. Step 2, subtract your current operating weight, which is your empty plane plus crew and fuel. The result you get in Step 3 is your maximum allowed traffic load. If the combined weight of your passengers, bags, and cargo goes over this number, somebody or something is staying behind. No exceptions.
Which brings us to Section 4, Cargo Distribution and Balance. Because it's not just about how much weight you have, it's about exactly where you put it inside the holds down beneath the passenger cabin. Loading cargo is basically like playing a really high-stakes game of Tetris, but with very strict rules. If you have dangerous goods or special cargo, you have to isolate them. You might even close off an entire compartment, like Hold 4, so absolutely nothing else goes in there. Mail usually goes right into Hold 1. Passenger baggage, that's typically loaded into Hold 3, precisely because it's near the main exit for super fast retrieval once you hit the terminal. Once those non-negotiables are set, you evenly divide whatever cargo is left across the available holds just to keep the physical balance of the aircraft perfectly neutral.
Now, what's really fascinating about all this is the underlying physics concept that makes it work. It's called the moment. A moment is simply the weight of an object multiplied by its distance from a specific reference point on the plane. Think of a standard seesaw on a playground. A really small child sitting way far out from the center can perfectly balance a heavy adult who's sitting super close to the center. Same principle here. Every single passenger, every single suitcase creates a moment that pushes the aircraft's center of gravity either forward toward the nose or aft toward the tail.
Section 5, Trim and CG Index. And this brings us to the most visually complex, yet honestly kind of brilliant part of the manual load sheet. If you've ever seen one of these manual load sheets, it looks like a crazy zigzagging maze. But here is the step-by-step logic to it. You start right at the top with your dry operating weight index. Let's just say it's 45. You draw a line straight down. Then, for every block of passengers in the forward, middle, or rear cabins, you shift your line specific units to the left or the right. Draw down again and shift left or right for your cargo holds. Finally, you adjust for the fuel index. It's essentially a mechanical, graphical way of doing super complex physics algebra just by drawing a line on a grid.
And this brilliantly illustrates our ultimate goal, the center of gravity envelope. Wherever your zigzag line finally stops at the very bottom of the page, that is your actual calculated CG. And it must fall inside the safe envelope, right between the forward limit and the aft limit. If your final dot lands outside that box, there's no debate. The plane simply cannot fly. You have to physically go out and move passengers or cargo until that dot is safely back inside the envelope. Plus, this exact CG value is what tells the pilots exactly how to set their horizontal stabilizer trim for a safe takeoff.
Section 6, Automation and Future Solutions. As you can probably guess, doing all this complex math by hand under immense time pressure while the plane is sitting at the gate definitely leaves room for human error. So, modern digital systems are stepping up to handle this massive mathematical burden. Take a listen to this really powerful insight from Avionica. They're a leader in digital weight and balance solutions. They state that their system, quote, offers full automation, generating more than 80% of final load sheet autonomously, end quote. I mean, imagine the relief for load controllers and dispatchers. A zero-click load sheet that practically builds itself. It drastically cuts down on the manual data entry that can so easily cause a calculation error.
The perks of going digital like this? Absolutely incredible. Autoload calculations can instantly validate structural limits, meaning you'll never accidentally push past that 79,000 kilogram ceiling we talked about earlier. The software just automatically handles the legal separation of dangerous goods, and maybe the coolest part? It allows for a completely paperless workflow. The ramp agent out on the tarmac holding a tablet is looking at the exact same real-time data as the load controller sitting in the office. If a passenger misses their flight, the digital trim shifts instantly across the whole system.
But I want to leave you with one final thought today. Even if the software calculates the center of gravity perfectly and the digital envelope on the screen is glowing bright green, who makes the ultimate final check? The answer is always the human crew. Whether you're using a pencil at a paper grid or cutting-edge software like Avionica, human oversight remains our ultimate safety net. A pilot still has to feel the aircraft, a loadmaster still has to verify the hold. Automation gives us incredible precision, for sure, but human awareness, that is what guarantees our safety.